Now let's discuss about how we can determine the year, month, day based on the rotation and revolution of Earth and the positions of the Sun, Moon, etc. as we have observed. So you know that we are determining the year, the time on Earth based on the rotation and revolution of Earth as well as the positions of the Sun or Moon or some fixed stars. So we will discuss, first of all we will discuss how we can determine the year. Year is actually based on the passage of Sun at different reference points. That is we know that the Sun is when we observe the Sun is moving around this Earth. So Sun will traces different positions and we can choose different reference points to mark the position of the Sun. So based on that we can discuss three types of year. One is called the tropical year, the second one is called the sidereal year, and the third one is called the anomalistic year. So first of all let's see what is a tropical year is. Tropical year is actually time interval between two successive passages of the Sun through the first point of Aries. Aries is actually the first sign of the 12 zodiac symbols. You may be heard about these symbols, the Aries, Taurus, Leo, etc. So 12 zodiac symbols are there. Of this, that means the entire 360 degree has been divided into 12 portions of 30 degrees each, and this symbols represents some of the particular symbols, and it is mainly used by the astrologers. So out of these 12 zodiac symbols, Aries is the first sign of it, and this tropical year is defined as the successive passages of the Sun through the first point of Aries. That means it is the mean interval between the vernal equinoxes. So vernal equinox is the Sun's position as it crosses the celestial equator going north. That means if you consider the reference ellipse as this one, and the Earth is at the center. So this is the reference. Suppose Sun is what we are observing is Sun is revolving round the Earth. So suppose this is the path of the Sun, and suppose this is the orbit of the Sun. The orbit of Sun is called ecliptic. So this is the ecliptic of Sun around the Earth. So ecliptic means it is the relative path of the Sun around the Earth is called the ecliptic. So it is the passage of the locus of points which is traced by the Sun in the celestial sphere. So here it is the southern part. These parts are the southern parts of the reference plane, and these are the northern part. So this is the point which we call it as the vernal equinox. That is, the vernal equinox is the Sun's position as it crosses the celestial equator going north. So this is the celestial equator. So with respect to the celestial equator, this is the relative path of the sun, which is called the ecliptic. So the meeting point of the ecliptic going north with respect to the celestial equator is called vernal equinox, and which is chosen to be the 0th hour of the right ascension. The right ascension and the declination are the two systems used to locate the points on the celestial sphere, similar to the latitude and longitude, which is used to locate the positions on the surface of Earth. So declination is similar to the latitude, and right ascension is similar to the declination. So right ascension is similar to the longitude. So tropically here we can define in this way: it is the mean interval between the two vernal equinoxes. That means it is the time taken by the sun to travel or to pass successively through the meeting points of the celestial equator with the ecliptic. So one tropical year is exactly this much, that is 365.2422 mean solar days. We will discuss what is mean solar day while discussing the day. So it is exactly, we can say that 365 days, 5 hours, 48 minutes and 46 seconds. And you know that one day is 24 hours. So it is 29, actually 365 into 24 plus 5 hours total, plus 48 minutes and 46 seconds. And this tropical year is referred to as the year of seasons. Based on this one, we can have different seasons. The second one is the sidereal year. Sidereal year is actually, here the reference point is the fixed stars. So it is actually represents the time interval between two successive passages of the sun through the same point relative to fixed stars. So fixed stars are the stars which are always fixed in positions. Some of the stars, if you observe the night sky, will have a change in position as the days are going or as years are going, but the fixed stars almost have a fixed position when we consider the human lifetime. So when we are calculating the time interval between the two successive passages of the sun through same point related to the fixed stars, which is called a sidereal year, and which actually represents the true period of Earth's revolution around the sun. Because the fixed stars are fixed in position, so it actually represents the true period of Earth's revolution around the sun. But the tropical year is based on the vernal equinox. The vernal equinox has a shift in change during every year, that we will discuss later. And exactly the one sidereal year is 2564 mean solar days. That means 365 days, 6 hours, 9 minutes and 9.5 seconds. So tropical year is based on the reference point of the first point of the Aries. Earth is based on the reference point is the vernal equinox. So in the sidereal year, the reference point is with respect to the fixed stars, and the third one is the anomalistic year, which is the interval between two successive passages of the sun through the apogee. Apogee means you know that when the sun is farthest from the earth, which is called the apogee. So when if we determine the farthest positions of the sun, successive positions of the sun, we can get a time interval between these two, and which is called the anomalistic year. That can be usually observed by just by calculating the angular diameter of the sun. When the angular diameter of the sun is least in successively, we will take those two time interval which shows the least angular diameters of the sun, which will give us the anomalistic year. One anomalistic year is actually 365.2596 mean solar days. Due to these perturbations of the planets, the apogee moves forward at a rate of 11 seconds per annum. So which makes this difference. If there is no perturbations of the other planet, then the positions of the sun will be almost always will be the same, so there will not be any change in the positions of the apogee. But due to the perturbation means due to the gravitational force of other planets on the sun and the earth system, there will be a relative change in positions of this apogee and perigee. Now if you consider this tropical year, it is about 20 minutes shorter than the true period of Earth's revolution round the sun, that is the sidereal year. It is actually sidereal year. The reason is that the first point of Aries has a slow backward motion along the ecliptic, that is 1 degree in 72 years. Very short, but it is a little bit difference will be there when compared with the true period of revolution of Earth around the sun. So since the Aries has a slow backward motion, our reference point is the first sign of the Aries, or first point of Aries is the reference point which has a slow backward motion, which gives a shorter time period compared to the actual time period of revolution of Earth around the sun. Now if we consider the actual period of revolution of Earth around sun, that means relative to the fixed stars, the sun describes 360 degree in a sidereal year. Again it is here, sorry for the mistake, sidereal year. And during tropical year, we know that Aries has a backward motion, so it will describes only 360 degree minus 50.26 seconds in a tropical year. And we have seen that mentioned that due to the perturbations of the other planets, the positions of the apogee has a forward movement. So in an anomalistic year, the sun describes an angle of 360 degree plus 11.25 seconds in an anomalistic year. So exactly sun describes 360 degree in a sidereal year, so it is called true period of revolution of Earth, since it is based on the positions of the fixed stars. So that's all about the year. Now we will discuss about the month, that we can discuss in the next lecture. Thank you.